Hello, everyone. Good to be here, and congratulations to all the exciting speakers so far. I've been listening quietly, and it's been very impressive. Eloha and Indira, very impressive. I will make this as quickly as possible, given that we are behind schedule. And I would like to share. I have a short presentation. So I'd like to go ahead and share that. Okay, I think you need to, I'll just go ahead whilst we try to work out. I think someone's sharing, so they need to stop sharing so I can. Okay, whilst that loads up, I will talk a bit about myself and the work I do. My name is Binitie. I'm based out of Ghana. I've spent the last 20-something years building and scaling tech companies. I'm on my probably fourth company at the moment. I am the CEO of a deep tech, one of Africa's 3 privately funded deep tech research companies. And what we do is partner with industry and try and turn advanced technology into meaningful products which are ready for the market. Interestingly today, one of our companies, Rancard, is 20 years old, and we're celebrating the 20th anniversary. Some of the other companies, such as Iroko TV and a few others, will be going public soon. I hope my screen is visible now.
Yes, it's visible.
Awesome. So I will jump straight into it. Clearspace Labs works on radical new technologies to solve some of the world's hardest problems. We find innovative ways to turn these problems into the next generation of impactful businesses. I'm a tech entrepreneur, engineer, husband, daddy of 2, an industry background in healthcare, payments, AI, educated at tech in Ghana, MIT and Oxford. And I am a founder or co-founder of quite a few companies. I hold a patent for work done in deep tech and AI. And my body of work include projects for many of the world's leading tech companies, including Google, Intel, Facebook, General Electric, and a slew of other media companies. But today I want to talk to you about sustainability and artificial intelligence. Over the last, so I spent the first sort of 80 years of my career running projects and building out critical infrastructure for many of the world's leading companies in different markets. I was educated in Ghana for the most part of, and then went to do a research master's at Oxford and did a postgraduate in innovation management at MIT. And across this journey, I think I came to an important realization that I needed personally to make a change from being the guy who built products to being the guy who built teams that build products. And after Intel acquired a company, or a large part of a company, in 2012, my first company, Rancard. And after that, I made a decision to focus on helping other businesses solve their innovation challenges, which is pretty much what I've done throughout all my career, just done this as a commercial. So very important transition for me. The question was, how do you sustain and fund deep tech research in Africa at scale? Deep tech is extremely expensive to run because you're usually dealing with the high end, and very often there are very few markets. you create your own market. You have to be your own rainmaker. So since we launched Clearspace Clearspace was born out of the research arm of my founding company, Rancard. And since then, in 2015, we have a presence across 5 countries. We've launched 6 companies, and we've created over 100 million in value um, in the last few years. So we're driven by a best-in-class research and dev team, and we are focused on scaling opportunities in healthcare, fintech, food security, and housing. And the approach is to bridge radical technology and a winning culture to create new businesses. Um, One of the most exciting projects I think I've worked on was a project we called Fish Reefs. And the goal was, how do we protect the ocean but feed people, millions of people, sustainably? This was the question we're asking ourselves. How did we get here? I had stumbled upon a study whilst working, doing some work for an oil company on how close we are to a catastrophe across the west coast of Africa for 2 reasons. One, overfishing. Two, oil exploration activities, and its absolute decimation of the seabed. Now, the West Africa has a unique problem because we have mostly the West African seabed is mostly sandy, and what this means is that um, fish reefs, which are the foundation, coral reefs, which are the foundation of ocean life, do not form easily. And actually, the only places where we find lots of fish reef are around oil rigs. So a large part of our fish stock comes from the installations which are being done for oil activities. And this creates a huge conflict with local communities, conflict with fisher folk, conflict. It's just really problematic. And the problem is getting worse. So fish stocks are depleting, etc. This is the kind of problem we like to take on. It has huge impact. It solves problems of scale. And we believe that we can, using a combination of policy and technology, um, create a sustainable ecosystem which drives benefits for everyone. So we sat down, had a meeting with a number of oil companies with a goal to deploy 44,000 reefs across the west coast of Africa. But we had 2 problems. One, we needed to predictably demonstrate that the solution would build out or will create fish stocks at a rate faster than they were being depleted. So we had a predictability problem. And the idea here is really that you're going to go to the bottom of the sea, create an artificial ecosystem, and do it in such a manner that its rate of production was faster than the rate at which it was being fished, as if the challenges were not enough. Don't throw in piracy and a ton of other problems which happen across the West African sea coast. So picked up this ambitious project. We partnered and invested in a company out of California called the Fish Reef Project. And we came up with an innovative model using AI to predict um, the with a design, a patent pending design for the generation of artificial reefs. Now, there isn't a lot of science data across the seabed of Africa. And so we had to reference data models from North America, from Papua New Guinea, from the East Atlantic seaboard. And then using a technique called transfer learning in AI, we needed to predict out what new models would look like for the West African coast, because we have very little data, and putting this data together is super expensive. So we take on these parameters, build out data sets from here, and then introduce new conditions and variations which allow us produce a new set of designs. So you want that these designs can be printed by local communities, they're sustainable, they either are taking advantage of marine grade bioplastics marine grade plastics and turn them into biofeasible material, or you're using what are called a form of concrete, a form of marine grade concrete to build these out. And then develop a design which can actually be rolled out and deployed across the seabed, and get doing a combination with oil companies and governments, get them to fund the project using royalties. So this sort of project, as you can see, is, yes, there is significant amounts of technology. I mean, unbelievable amount of man hours go into designing and building something like this. And then there is also the rollout. So it's not enough to sit in a lab and have your smart people come up with new models. You then need to sort of do the grunt work, which is build this out on the ocean floor. So physically go out there, deploy reefs, and begin to see the impact of that. I was just trying to put a quick high level understanding of how transfer learning models work in AI. I'm sure that would be pretty boring, so I'll skip that and jump in. But the basic idea is there are several techniques for doing this. You can do this either visually, so you're sampling data because you're dealing with at the bottom of the ocean, you're sampling data using cameras, and you're transferring that, using that data based on a sampling path and a number of techniques, and using that to create new models for what your reef design should look like, because you want to be efficient in terms of cost. And typically this is what it looks like once, this is under the seabed. So once you have designed these, you need to essentially print them and deploy these right across the coast to create sustainable models.